Alright, in this next section, I'm going to show you how to debug Quill. And in particular, how to, say, debug the parser. And I'm going to show it to you in two ways. There are basically two ways to debug Quill. And if you look at contributing.md, you can have a look. So there are two ways to do it. The first way is debugging macros by remote debugging SBT, which is basically you launch an SBT terminal and you debug in there. The second way to do it is to debug directly from inside of IntelliJ by making a run target that basically runs Scala's compiler in debug mode, the main function in there directly inside of IntelliJ. So the instructions are here, but I'll be just going through that and with a couple of pointers. So we'll go through both methods. We'll go through this one first. Basically, we're going to instrument a remote debugger into an SBT session and debug that way. Now, okay, let's do this. Let's do this. And let's do. Whoops, I think actually initially I had it here. And so what we're going to do is we're going to fire up SBT, and we need to compile Quill, of course, so I'm assuming you've got it compiled already. Now, actually, well, there we go. Let's see if it's compiled. Let's actually do a docker ps to see if I have the daemons running, because compiling Quill does require, okay, yeah, it does. Okay, so let's do compile, and let's make sure the project is compiled. And then we're going to exit out of SBT again, and then we're going to launch it in debug mode, because we need to make sure that everything is compiled first in order for this to work. Because one thing that you really don't want to do is you don't want to recompile the entirety of Quill in debug mode. That's kind of bad, or kind of slow, that is to say. But okay, we're good to go. We're all compiled. Let's exit out of that. Now, one thing, so you start SBT in debug mode by doing JVM debug and then the port that you want to debug on. But the thing is that there's one more argument that you want to run if you want to be able to quickly iterate on SBT code. And what you want to do is you want to say JVM opts, I think env JVM opts equals to, and that's how you specify the JVM options that are going into SBT, and you do de-exclude tests equals to true. Now this is actually an argument that exists inside of the build.sbt, and you'll see it here. What this thing does is it basically tells the SBT build settings to not recompile tests. And the reason why we want to set this in order to be able to quickly iterate on something is because when we change something, for example, we change the parser quickly, well, the code in the parser will be changed, and as a result, not only will all the production code be changed, all the tests will be changed as well. And the challenge is that the tests take quite a long time to recompile because there are a lot of queries and there are a lot of tests. So if you want to be able to quickly iterate this way, you've probably got to disable the test recompile. So here's the parser, right? And we'll change the parser in some way, some simple way, and then we'll recompile it and instrument the debugger. So let's start it up. Okay. Now we've started up SBT. Now, so the next thing you need to do is create a file. Typically, when I'm writing new features of Quill, there are a couple of modules that are the main ones that are going to be the point of contact. If you're debugging, for example, if you're working on the Quill context, like Quill JDBC or Quill Spark over here, then typically what you'll want to do is make changes directly inside of them. Now, however, if you're debugging things like, let's say, the core syntax tree, like the core abstract syntax tree, and, if you're modifying this thing, the consequence of modifying this thing is a massive recompilation of Quill code. So chances are what you'll want to do is you'll want to go into the specific project or the specific subproject of Quill that you're working with. So in this case, whenever I'm dealing with stuff inside the abstract syntax tree and really stuff that doesn't have to do with project-specific contexts, I go to Quill SQL. I go to this module. If I'm going to be modifying something like Quill JDBC, I will be typically going to that module. But that's the thing that I do. Now, let's see. Let's load and unload. Actually, yeah, that's fine. We don't need to do that here. Typically, if you're running a debug cycle inside of IntelliJ directly, you'll want to load or unload modules, but we'll show you that later. That's not necessary now. So let's go inside of parsing again, and we'll just make a change to the parser and show you how to recompile. Well, here we have a change that we've made previously, but let's say we're going here, implied query schema, and we just make this simple change. And we just want to write it into a variable before returning it. And this is actually, unfortunately, with the state of debuggers for Scala being what they are, sometimes you have to do this when you want to actually be able to see what something is going to be before you return it. If it's this sort of style, then it's actually kind of hard in a breakpoint debugger to see what it's going to be before it comes out. So some amount of messing around with the code is needed sometimes, actually, for proper breakpoint debugging. But anyhow, so let's set a debug point here. But let's go back here again. We don't want to recompile the entire source code again. I mean, we do eventually, but we don't want to do it now, because we just want to debug what happens in the parser when we change it. Now, that's why we go to project Quill SQL, but it's actually not Quill SQL. It's SQL JVM. There's Quill SQL JVM and Quill SQL JS. In fact, one second. In fact, if you want to see, let's see, can you do projects.toList? Pull that. 1 second. Let's see. projects dot value to list. Yeah, I'm not sure. Oh, there they are, just projects. So you can see the projects that actually exist. We have SQL.js, SQL.jvm are the actual projects. The way that this works is that the portable ones are the ones actually that are going to be shared across regular Quill and Dotty, because they don't have anything macro related. The other ones are these, Quill SQL JVM and JS, and Quill Core JVM and JS, because Quill also supports Scala JS and in JavaScript builds. But anyhow, in this case, we're going to set project to Quill SQL JVM. And now, let's change the parser. But here's the thing, actually. What we want when we want to debug this thing is that we actually want to debug it with reference to some query, right? Like, what code are we running the parsing on, right? So in this case, you'll want to actually create some kind of query that during compilation it's going to be running that will enter this parsing section. So what you want to do for that is typically, Quill SQL, and you'll want to create some kind of file that will actually do that. Now, this is pretty simple. Just create it. I like to call it MySQL test.scala. Notice that I've created it. Oh, whoops. Excuse me. It's a quirk of IntelliJ that when you do MySQL test, that if you do .scala here, it doesn't understand you want to create a Scala file. It thinks that this is a package and that this is your file. Okay, IntelliJ could be a little smarter about that, but whatever. Let's do that now. Object def main args array string unit. Okay. Now let's create the context. Now normally we would have to do, and we can actually import io.getquill._. We are inside io.getquill in this case. It's not actually necessary, but whatever. Val ctx, and let's create a mirror context. Again, if we were debugging something like Quill, let's say Quill JDBC, right, then we'd be creating a JDBC context. But in this case, we're just debugging the mirror context because we are in Quill SQL, so it debugs a context that just creates the query and doesn't actually have various effect machinery to execute it. So let's do this. Let's do mirror SQL context, or mirror, what is this? Mirror SQL mirror context, excuse me. Maybe need to change that or rename it. Anyway, so in this case we're going to be doing, let's do Postgres dialect and let's do literal. Right, Postgres dialect means we're using the Postgres dialect of SQL that we're compiling to, and literal means that variables of a case class, for example, let's do first name, last name, age. Right. That means that the SQL query will look at this directly as opposed to translating this to snake case. Now, let's write our query. Say, oh, and of course we have to import the context. Let's do query person filter p2 first name equal to Joe. Okay, then run this thing. And also, because this returns something, the compiler will complain about having a return value from which we're doing nothing if we don't print it out, so let's do that as well. And by the way, you don't actually have to do this part. Well, for the parser you don't, because the parser is run in this quotation block. Now, the other way I'm going to show it, actually you do need to do a run function, otherwise it doesn't work quite right. But either way works. You don't actually, when you're debugging it directly from the remote debug SVT, you don't need to do this. But anyhow, let's do that. And now, what we want to do is add configuration. And we want to do a remote debug. There it is, remote. And let's do remote debug 505. Remote debug, a JVM running on port 5005. So, apply, OK. And we already have this thing listening to port 505, which, by the way, it says up here that we're listening on port 505. And let's start it. So it's connected. So now, the last thing we need to do is compile. Compiling. And now, what you should see shortly is that this breakpoint will be hit. And there it is. It actually took a little bit the first time, but there it is. Breakpoint is hit. Now let's take a look at what this variable is. There's a query schema of person. We've parsed it. We can look at the quat. Quat is Quill application types, and that's an upcoming change that's going to happen in Quill very soon. So there it is. We've debugged it. Now we can keep this thing running. You know, do our typical run. Let's see, where's our debugging action? Step over, step out. Oh, we've got it right here. Step over, etc., etc. Where's step out? Oh, step out. You step out. Is this gonna fail? Let's do. I don't think so. Debugging actions. Oh, resume program. Okay. Now, no, that's all as well. You can actually see. Oh wait, no, looks like the debugger failed because we don't actually need to import io.getQuill because we are in io.getQuill. Normally you need to do that, but in this case we don't. So let's. But by the way, it did print our query. And now it's compiling again. Oh, look at that. We hit our breakpoint again. Let's resume the application. I'm just using shortcuts to continue the debugging. There we go. There's our query again. Now here's something very interesting. Let's say that we make another modification. Right, let's make a modification here. And then we return. Right. Let's make a breakpoint here. I don't know why it says that, actually. Oh, I guess it knows ahead of time. Interesting. So, interesting. Anyway, let's compile it again. Compiling, compiling, compiling. This is actually why... Oh, there it is. Yeah. Notice how our breakpoint was not hit. And this is super important to understand. Unless you actually change this code, the Scala macro will not rerun, because the macro, this macro run and quote, right? These are Scala macros. They will not run inside of the compiler unless there's a recompilation, right? They run, they take out this code, they splice the code into its place that's needed, and then if this file does not change, they will not rerun. You have to change this file. And you can change it in the most trivial way. Most of the time, you can just do hello, adding a comment. Something like that. Once you've done that, then you could do recompilation. And then the breakpoint will be hit. Oh, we can step out. And we're good. Oh, by the way, filter was not hit. We have a filter here. I'm actually... Oh, nope, there it is. I was surprised by that. It's just a little slow. So you have to be mindful that sometimes the breakpoint will not get hit because the debugger itself can sometimes be a little slow. But anyway, let's resume the application. And now again, it prints out our query and we're done. All right? So that's something to keep in mind. You actively have to change the program for the debugging to work. Now, let's shut down SBT here, and let me show you a different way to debug things. The other major way to debug things is this other way. Right here. Debug macros by launching a session. Now I actually show you, make this -d debug macro equals true. All right. And by the way, because we're going to be launching things directly inside of IntelliJ, you want to set the SBT that's running inside of IntelliJ to have this argument. So let's do that. But let's do that first. Where is this? File settings, tool settings? No, IntelliJ IDEA preferences. So here are our SBT settings, and these VM parameters is where you want to add this. But I also want to show you something else. This time around, I want to debug not the parser. I want to actually show you how to run, or how to actually debug, some of the phases of Quill's query compiler. And I want to show you how to look at the query compiler and how to see some of the things that happen inside. So there are some other variables that we use for that. So let's take a look at that. I don't think I have it here. at least. Oh yes, here we go. I have it right here. What we want to do is we want to enable tracing of the compilation. So that's this argument. This argument enables the tracing of the various phases of the query compiler using color. This thing, by the way, they'll be printed out using pprint, so thank you to Lee. And the other thing we want to do is enable the kinds of places the traces are going to happen. So we're going to enable, I guess, normalization and standard. Also, there's another one called SQL there's another argument there. Let me show you in 1 second. So let's go back to here. Now, let's add them. Trace enabled to enable tracing. Trace color to enable tracing in colors, because it makes it easier to tell. And let's enable trace types. Don't want alias tracing. In fact, let's just do the most simple kind of tracing, just the top level compilation phases, which is going to be SQL. So good. Now apply. Okay. And now the key thing is we have to restart SBT. So let's stop it. Let's rerun it. And now you'll actually see, look at that, though these are the arguments that we've actually passed into the SBT launcher. Now let's wait for that to come up. Meanwhile, in order to actually run this stuff, what we need to do is we need to set up the actual main function that's going to run the Scala compiler. Again, because Quill queries run during compilation. Let's go to Edit Configurations, New Application. Oh, excuse me, there's one other thing that you need to do before we do this that I forgot about. Let's close up SBT first. And what we need to do, we need to add one other important argument here. Specifically, when you're doing compilation inside of IntelliJ, you need to add this argument here, Debug Macro. Let's add that there. And what you need to do is you need to restart SBT. Now, what Debug Macro does is that it actually includes the libraries needed in Quill's dependencies for doing this kind of debugging. And that is specifically the Scala compiler. So if you look at build.sbt, you can actually look at Debug Macro. You actually need to include Scala library, Scala compiler, in order to set up what we're about to set up. And not only that, when you actually enable this flag, what you need to do is you need to go to this SBT and re-import the projects. Then this is going to take a minute in IntelliJ. Blah, 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 blah. Extracting project structure, blah, blah, blah. This could take a minute or two, and you've got to wait patiently again for, as IntelliJ reads the entire contents of all of your build file or your build files, and reads them back in. So let's wait for that to get done. All right, we've imported now. What is this? Sometimes IntelliJ does not understand build.sbt, and when I say sometimes, I mean quite frequently. Anyhow, so let's keep our breakpoints inside of the parser, but let's also look at something else. Let's look at the SBT compilation phases. Let's take a look at SQL Normalize. SQL normalizations. Oops, not there. That's a tracing type that represents SQL normalizations. Here it is. That's actually SQL normalizations. Notice how we've used SQL normalizations as our type of tracing. That is to say, in here we've said SQL, right? This is that. So what does this mean practically? These are the compilation phases of Quill. And when we compile Quill, it actually goes through these phases and looks and says what the syntax tree is. Now, by the way, if you just want to look at the syntax tree of Quill, you just do quill.ast. Right? You can do that, and that'll show you the AST. Right? You could do q.ast, and then you could print line of the AST. Now the AST is case classes, so it's much better to print it out using some utility that nicely prints out case classes. So you'll typically want to do use something like pprint. Because Quill uses pprint, you can actually do something like io.getquill.util.messages.qprint that, and print line of that. That'll essentially do the same thing. Or you could just import qprint, and anyway. But oh, and by the way, you can always if you're using Ammonite, for example, right, you can debug Quill in Ammonite. If you're using something like Ammonite, you can do it there, but we're not going to do that right now. So let's go to SQL Normalize, and let's actually go into one of the phases. Let's go into one of the build phases. Let's go into expand join, right? And these are different kinds of phases that happen during Quill normalization. Actually, let's not do expand join. Let's do expand distinct. This is some particular things that need to happen to a query when you have distincts, or when a part of a query has a distinct. So let's do, instead of filter, for example, let's do .map. Let's say p2p dot first name, and let's do .distinct. So then we should actually, in addition to going into the parser, we should end up going into this expansion phase here. And we're not going to go into here because this is for hidden properties. We're going to go into here. We're going to go into here. So let's kick it off. Now again, you need to set up the application that you're going to use to debug Quill. And again, this is the Scala compiler that gets instrumented. So let's go through the settings that you need to enter. right here, and right here, excuse me, and it explains. The main class, Scala tools.nsc.main. This is the actual Scala compiler. VM options, use JavaCP. Program arguments. And this is where you need to actually point to your MySQL test file. There are various ways that you can avoid having to type the absolute path of the whole thing into here. And I go through some of those, but we'll just use this meanwhile, just to simplify. And in this case, this is going to be my home directory. So this is going to be users, I believe, /git. Let's take a look at that quickly. Yeah. Oops, /git, or excuse me, /quill. Oh no, that's already in there. So this is gonna be blah 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 mytest.scala. Okay. Now, working directory is fine. Oops. And we want the class path to be quill-sql jvm. Now, the other very important thing here is to set not build, but build no error check. Here's why. Imagine that your user code inside of this file here, MySQL test, imagine that you screwed this up and this is wrong. Well, what's going to happen is that when it actually builds, it won't run your code because your code is bad. So what you need to do is you need to make sure to run this thing even if the code doesn't compile, because guess what? If your code doesn't compile, it may not compile because the Quill macros have failed, but you need to compile it anyway to actually be able to debug the Quill macros that failed. So it's sort of like a catch-22. But that's why you need to do build no error check. So, now here's the thing, right? If your code is compiled because of something that's wrong inside of Scala, well, you can't typically run the macro engine anyway because the Scala compiler itself has failed. Or if you failed to write, some transformation in Quill or something like that correctly, and there's a compile error in there, right? You won't be able to actually run the compiler at the place at which it's going to, be debugging Quill code, right? So for example, if you've done something like, if you've, say, messed up in here, and there's something like that, right? This thing won't be able to compile, so you'll never be able to hit one of these breakpoints, right? But here's the thing. If you've messed up in here, well, you also can't do that. But let's say you do something like, system.out.println hello, right? Well, that's going to break inside of Quill. But in order to debug that thing, you need to actually run the Quill macros. You have to run the Quill macros. So that's why, but here's the thing, unless you say build no error check, it's not even going to get that far. So that's basically why we enable that. So anyhow, now since we've done this, let's call it remote debug MySQL test. So we've got some breakpoints inside of parsing, we've got some breakpoints inside of expand distinct, which I think we will hit. And of course, we've changed this file already, like we've added .map and .distinct, right? If we didn't change the file, we'd have to change it and do like hello or something like that. But we have already changed it, so we don't need to do that. And let's run the remote debug. Or not the remote debug, but let's run the debug compilation. Okay, so here we hit the breakpoint inside of the parser, right? Because the parser is going to run first. Now here's the interesting part. We've already run through some of these build phases. Flatten option operation, simplify null checks, normalize, rename properties, expand distinct, etc., expand join. We've run through these, actually. And the reason we've already run through these is simply because this quotation here, this part of the macro, has already run. And this is one of these tricky things about using this remote debugging thing here, where it will run, but there might be a previous compilation cycle that's already happened. But anyhow, let's resume the application, and then let's see. Are we going to hit this breakpoint inside of this expand distinct? No. Looks like we're not. Let's actually set a breakpoint inside of SQL Normalize. Actually, not sure that we'll hit that either, but let's give it a shot. Let's hit a break. Let's do a breakpoint here. Let's change this. Oops. And now we're rerunning it. Well, there we are in our parser. Let's see what's happened here. Okay, we've run our parser. We're in this debug setting here. Let's go back to the debugger here. Let's resume. And looks like, oh no, there we are, inside of SQL Normalize. And in fact, let's set a breakpoint directly and expand distinct and see if we can hit it. Let's set a breakpoint here. Oh, so now we did hit it here. So let's see. Let's walk through. Let's walk through these. You know, and now we can actually start walking through. Looks like it did not hit that breakpoint that I was intending to show you, which was this guy down here. I'm actually not sure why. Maybe because it had hit something even above this. But let's actually look at the AST. Let's look at the AST when we started. The AST when we started was this, map distinct map. This was the original AST as it came out of the parser. Now if you actually notice, right, the parsing, right, this produces an AST. This is entity, some other things. In fact, we can print the AST that comes out of the parser. It's actually also pretty simple. Let's go to the apply function. Actually, unapply, because apply just calls unapply. Let's look at where this thing is invoked. Oops. No, 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 no. Not what I want. Tree match source. And apply source. Where are we invoking AST parser? Actually, one second. Where is the entry point to this? Where's the entry point to this initial clause? Actually, I'm not sure that it's here. One second. Whoops. The actual entry point is inside of quotation. Here we go. The entry point is here. AST parser. It's actually easy to get confusing because this file is called parser, or it's actually called parsing, but still, parser is not the initialization. It's this entire thing. The parsing is a trait that actually gets tacked onto the quotation. Gets tacked onto the quotation via a trait, and then the AST parser is used directly inside of the quote macro, right? So then when you're doing quote, right, this thing here is actually this macro here, and it's calling the AST parser directly from there. So that's where that is. But anyway, so there are ASTs, and by the way, if we want to actually see the AST that goes directly into, or if we want to see the AST that comes directly out of here, or comes directly out of any clause from here, then we can typically add some kind of print line statement. So let's go back to something like, let's say, implied query schema. All right, so let's say we want to print this thing out. I actually print it out to the console. io.getQuill.util.messages.qprint, and then we can actually print this thing here. This will print it out in color. If you want to do not in color, it's .plaintext. Render, or just that, is going to be in color, just by default. So, you can do something like that. And if we want to see this, let's change it. Let's kick this debugging cycle off again. And there we go. We actually look at console here. Well, there it is. Returning part of the tree. Now here's the interesting part, actually. Let's go back to SQL Normalize. And let's set some breakpoints. Let's set a breakpoint here. Let's set a breakpoint here. Set a breakpoint here. Right. So let's resume the application and see it hit some of these breakpoints. I think we're still, where are we? We're here. Okay. So let's see what's happened. Oh, whoops, where did we set our breakpoints? Oh no, we just set them later. Okay, whoopsie. Set a breakpoint here. Let's see what happened. We should have printed out what we're doing in these phases. Why haven't we? This is SQL normalizations trace type. Trace types equals to SQL. Should have printed. It should have printed the tree here. There we are. Let's see if we printed anything to the console. No, we haven't. Well, that's odd. I'm actually not sure why. It's interesting. I'm not sure why we didn't print to the console what these phases are. This is probably yet another one of these things that that makes this thing finicky. I'm fairly certain, actually, that if you run it from here, what you have to do is it's not JVMops, but it's SBTops. That was a dumb mistake that I made. In fact, let's do just SQL. Let's launch that. And there we go. And next up, let's change something here. And let's compile. Okay. Now let's attach it. Let's attach the breakpoint debugger. And now we can actually see the printouts here. Now let's actually attach the breakpoint debugger and compile again. We've changed the file. There we go. So now we hit this breakpoint. Let's go on. Let's look at the next major breakpoint, which is going to be inside the normalizations. We don't care about that. There we go. And now, let's see. Looks like we're here. We enabled the JVM opts, or the SBT opts. We're printing stuff here. Why haven't we printed the phases? Let's see. We're going through these phases here. Oh no, there they are. There they are. You have to actually be a little bit careful in how you set these breakpoints, actually, because when you set a breakpoint, right, it actually says, do you want that breakpoint to be the line that where this thing is first created, or when the stuff inside is being run? In this case, we want that. Same thing here. It's the stuff we care about when the stuff inside is being run. Well, in this case, it's that. So let's actually restart it just to show you what's going on. And let's actually run through these phases one by one, and let's show you what's going on. And again, you have to make sure to do the last option in this case, because it's when the stuff that's actually running inside of here, that's when you want to break. Okay. Let's make a change again. Let's clear the console. And let's actually, in the parser, let's ignore those, and let's start this whole thing back up. Okay. Now, the first thing, what's happened is we hit this. We said demarcate the original tree. Or sorry, demarcate the original tree. And then mark the external aliases. That's the first phase, but we haven't run it yet because that's where the breakpoint has been hit. So, look at that, original. That's where it's showing the tree. Now, next up, let's keep running. The next phase. Notice demarcate returning aliases has returned, or has printed, excuse me. Sometimes we get this because this is just a compilation message. It just gets garbled into our text. That happens occasionally. Next step. Let's go to the next phase. Simplify null checks. Notice how flatten option operation is done. So it says, this is our AST when we finished flatten option operation. Again, you have to ignore this garbled text. Next phase. Simplify null checks. Same thing. This is the phase that happened during simplify null checks, etc. So we go through these phases one by one. And each time it prints the AST that happened at the end of the phase. And this is basically the this is basically piece by piece what happens. Now, if you enable potentially more things, for example, let's say that we want to enable printing of normalizations. Excuse me. For example, we do SQL and norm here. Then what ends up happening is that we're going to be printing not only these phases here, but also stuff that happens inside of this thing here. So now we also print these things. So let's set a breakpoint inside of here, and you can, or let's set something inside here, and you can see that. Again, we have to connect, so modify the file. And let's compile. Okay, or set the project and then compile. So here are all of these phases here. Let's undo the breakpoints here. Let's run into here. And now the next phase, oh wait. We didn't actually, oh, because normalize, right, that's the other trick to understand. With this particular set of normalizations, unless you need to run this thing here inside of these normalizations, this thing will not actually run. And this is specific to this normalizations class. They only run when they have to. And the way that that happens is it goes through this particular phase and says, do we need something like that? So let's actually quickly take a look at this. So for example, if we have a situation where, let's say we have a flat join or something like that, where a flat join is nested, we need to do something like that. Or we have nested queries. So let's see what happens. Well, first let's finish this set of normalizations. Let's create a query that will have something nested. Let's do well, the easiest way to actually do nested is like that, right? The other way that you can have nesting is by doing .distinct, because that means that you need to do this part of the query before this part because it needs to be distinctified. So let's do that, and we should hit this. Let's see if that actually happens. Otherwise, we could try something more complex. So here we hit this SQL normalize phase. And now we're going to run the normalize apply, which is going to enter this loop here. So we're going to enter, oh, wait, come on. There we go. Let's see if this thing activates. I'm not sure that it will, but let's give it a shot. No, looks like it still won't. Let's see. I think we have to do something more complex. For example, let's try doing something like, let's say query person.nested, and then let's do .flatmap. And then, or let's put it in a for comprehension. That should be a little simpler to understand. Instead of nested, let's do distinct, and that'll force that to happen. And then let's do case class address. Let's add an ID to this, and then let's do the foreign key, street address. And that should be a proper nested query. It has to because it's distinct. I don't think there's any way to work around that. Let's try that. Let's try doing join a2 a.fk equal to p.id. Yield pa. I think this should do the trick. Let's run that thing. And let's see if it'll get into there. it again. There we go. So this actually starts to get interesting. You can, let's see. Wait, did we launch this thing correctly? Oh, wait. Are we inside of the normalize apply? No, we are now. So because now, since we're sitting inside of here, we ran the demarcate external aliases, flatten option operation, simplify null checks. We ran all of these phases already, so you can actually see the syntax tree as it printed it. So we can actually see, okay, we have a flat map, and then we have an inner join inside, where we have an entity inside there that we map there. And you can actually see how the tree transforms. We can see the whole process. So let's continue. So now we're here. Let's see if we're going to go into normalize. Oh, there we go. Normalize nested structures. And now we can see here, all the way here. So notice how we got to simplify null checks, which, by the way, was right here. And then before the next phase, then before this thing happens, we're inside of here, inside of normalize nested structures. And now we're seeing all sorts of this stuff come up, right? So basically, what we've said is, okay, let's start normalizing nested structures. And the way that phase works is that it starts from the outside. In general, the way that this entire system works is it started from the outside and then goes, or it started from the inside and then goes out and out and out. Right? So then we started with this part of the query, and again, this text is a little garbled here, so you just have to watch out for that. So normalizing nested structures basically recursively runs normalizations inside of all the nested things. So this thing, then this thing, then this thing. And it potentially does it a few times. So now, right, we're going to run through all of our normalizations that need to run in here, and only then are we going to resume and run this rename properties phase. So let's set a breakpoint inside of, let's set a breakpoint here, and let's continue running. So look at that. Finally, it said normalize. This is the final result of the normalizations. And here the normalizations ran, and they ran from here. And now finally, it says this thing has printed it out, so these are the normalizations. And so now we're sitting inside of here and rename properties. And now we can allow this printout to work. Let's set the next breakpoint in there. And now rename properties phase is completed. And so we're basically going to continue this way until we're done with all the transformation phases. And now here's our query. So this is basically the second way to debug the query. I want to show you one more interesting thing that you can do that actually doesn't involve remote debugging anything. It's a little trick that you can do just if you want to debug the normalization phases. Because you can't debug the parser this way, but if you just want to look at the normalization phases, and this is a completely runtime approach. So let's actually, let's exit out of here, and let's actually run. We don't even have to run SBT in this case. We can run this application directly from here. Now, what happens if you do .dynamic here is that it will forcibly run the query during runtime. Now, the query parsing phase still will happen during compile time because it's a macro, but the actual normalizations will run only during runtime. So that way, what you can do is you could set a breakpoint here, and then during normalization, you could set a breakpoint, or sorry, not, well, yes, but let's start with here. You can set a breakpoint in one of these places, and then let's set a breakpoint here just for reference. And then what you could do is you could compile this thing or you could debug this thing directly. So now what you'll see is before actually, hitting this statement, what will happen is because this thing is dynamic, this thing is going to be running during the inner transformations are going to be activated during runtime. So let's see what happens. Looks like it's building. Oh, whoops, excuse me. This is actually compiling the tests. Again, you have to be careful with that. And let's see, did I disable test compilation? Oh no, exclude tests equals to true. Why is this compiling all the tests? Oh, that's right. Looks like the class path was incorrectly selected. I don't know why, but it actually selects SQL.js sometimes for this when you first debug it. I'm not sure why, but anyhow, let's do that again. It has to be SQL.jvm. And there it is. Now, I think these parsing breakpoints should be hit, or sorry, not parsing, those will not be hit. I think these breakpoints should be hit as well. Let's see. I thought they were going to be hit first, but looks like that's not the case. Looks like they're not being hit. Wonder why. Let's try it again. Oh, there we go. Oh, okay. Well, they are being hit now. Okay. So what happens? Does this happen first, or does that happen first? Let's try to rerun this. Okay, that happens. That happens. That happens. Okay. Oh, then that happens. Okay. Okay. So now notice how it's interesting. We're actually debugging this code directly. And now we've hit a breakpoint inside of the normalizations. We have not hit the breakpoint that we made inside of the parser, quite interestingly, right? We still have some breakpoints here that we've made, but we will not hit them because these actually run during compile time, whatever you do. But because we did .dynamic here, these normalizations are running during runtime, and so you can actually, look at these normalizations even in your client application code by just doing .dynamic and then setting breakpoints inside of this file. So let's continue this. And oh, now we're going to hit this again. Okay, because again, it runs the outside first and then the inside again, and each time it runs a part of it, it hits this breakpoint again. So that's why we hit this thing several times. What's interesting actually is that notice that, I set variables in here. Now, if we're debugging during runtime, if we're hitting the compilation phases during runtime in a dynamic query, well, we can actually set these here, right? Where what's the shortcut here for multiple whatever. I don't remember the multiple cursor shortcut in here, but system.properties set property where we actually set the properties here. And if we set the properties here, well, we will actually see the phases happen when we run this thing. So let's kick it off. Okay. Let's continue. 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 Yes, this is going to happen a few times. Then this starts to happen. And we actually go through, look at that, right? We actually printed all of the phases, all of the compilation phases. And again, we're not debugging macros. This is all runtime, right? So this is just another interesting way that, that you can go through these things. So that's as far as I'd like to go here. So this is a third method that you can actually use to debug specifically query compilation phases. All right, so I guess that's it. This marks the conclusion of this session, so happy debugging. Where are we? Are we still recording?